Today we're going to learn how to divide fractions. This is a standard for 5th and 6th grade, and fractions are introduced in the upper elementary grade levels. This understanding is huge for middle school mathematics as it lays the groundwork for understanding unit rates and ratios. So let's get into it. Often the problem when learning about fractions has to deal with the fact that there are 4 different operations that we learn: adding, subtracting, multiplying, and dividing. There are so many different rules and tricks, and if we are simply just memorizing the rules, as time passes, we can't remember what to do or how to solve. Do I have to have like denominators when I'm adding? Which term am I supposed to flip? This is all part of why people struggle with and despise fractions. Remember, mathematicians practice math by making connections to things they already know. We need to connect our learning to real-world scenarios so that we can apply what we learn. We have 3 goals today. The first is to not only understand how to divide fractions, but why. This will help us when it comes to trying to remember which method to use for which operation. Our second goal is to learn 2 different methods for dividing fractions. First, we want to draw a fraction model. Secondly, we're going to use the trick skip, flip, multiply, also very similar or known as keep, change, flip. Our third and final goal is to solve fraction problems using division in a real-world context. Real quick, I've been teaching mathematics for over 17 years, from 6th grade all the way to high school algebra. Beyond the classroom, I've worked in a variety of instructional leadership roles, ranging from coordinating district-wide initiatives to developing curriculum, training teachers, to working with state and national organizations. My experience spans from kindergarten to 12th grade math learning, assessments, and instructional coaching. In addition to continuing my work in public schools, I also write and develop math curriculum for the Blaze Haven. My goal is to make math clear, approachable, and even fun so you can build confidence and finally feel like math is something you can do. Let's take a look at our vocabulary for this lesson. You know what separates a rookie from a pro? It's not just skill, it's language. Think about athletes. They don't just play the game, they speak the game. They know the plays, the calls, the signals. A musician doesn't just make noise, they understand notes, rhythm, and harmony. That language is what lets them create something powerful. Math is no different. If you want to think like a mathematician, you've got to talk like one. Vocabulary is the toolkit that lets you understand problems, explain your thinking, and connect ideas. Without it, you're guessing. With it, you're building. So every time you learn a math word, equation, ratio, coefficient, you're not just memorizing, you're claiming the language of mathematics. And once you can speak it, you can own it. That's how you go from feeling stuck to solving with confidence. Because real mathematicians aren't just people with answers, they're people who know the words to ask the right questions. So let's take a look at our vocabulary. Let's review our first term, whole number. It's a number without parts or decimals. Here are some examples. 0, 1, 2, and 3 are all whole numbers. Our next term is fraction. Fraction is part of a whole amount. It's written with a numerator and a denominator. An example is 3/4. So 3 is our numerator, the number on the top, 4 is our denominator, and 3/4, remember we're talking about part in comparison to a whole. 4 is representing how many sections or pieces are in one whole, and then 3 is the part that you get. So if you think of one whole apple and you slice it up into 4 slices, the denominator is representing how many slices there are in the total amount, and then the part that you get is 3. You get 3 out of the 4 slices, so you get 3/4 of an apple. Next, we have a mixed number. This is part of a whole amount written with a numerator and a denominator. It's one whole number and a fraction representing one total amount. So an example would be 2 and 3/4. 2 is the whole number and 3/4 is a fraction. A mixed number has the whole number 2 and the fraction 3/4 together, representing one amount, 2 and 3/4. Our next term is what we call an improper fraction. This is a fraction where the numerator, the number on the top, has a value that's greater than whatever the number is on the bottom. So an example would be 9/4. 9 is the numerator, 4 is the denominator, and 9 is greater than 4. So the number on the top, 9, is bigger than the number on the bottom, and we call this improper. It's an improper fraction. Our last term is a unit fraction, and this is a fraction whose numerator equals 1. It's basically how you write a whole number in fraction form. For example, 3 over 1 is a unit fraction representing the number 3. What does it really mean to divide something by a fraction? Remember, we want to think about how many pieces fit into that amount. So if we look at the problem 1 divided by 1/4, we're asking ourselves how many 1/4 are in a whole. That means there are 4 slices or 4 groups of 1/4 in a whole. Okay, let's look at our first example together. We're going to solve each problem by dividing, and right now we're dividing whole numbers by fractions. So we see our first problem is 1 divided by 1/3. So we have 1 whole here representing our 1, and then we're going to divide it into the size of a third. Remember, we're asking ourselves how many pieces of that size fit into this amount. So this amount is a third. How many thirds fit into this one whole? We can fit 1, 2, 3 thirds into the whole amount of 1. Okay, so skip, flip, multiply again is a trick that a lot of people use to help them remember what they're supposed to do when dividing fractions. So let's look at our first example here, number 1. And we're going to look at number 1, example 1, we have 2 divided by a 4th. Okay, so, and actually to the side, let's just check and see what this looks like with the method we just learned. Okay, if I had 2 whole cakes and I want to know how many slices would I have total if I cut them into fourths, okay, I would have 8 slices total, right? 1, 2, 3, 4. My 2 cakes I'm cutting into fourths. Each slice is the size of a fourth. Okay, now let's look at what that looks like if I'm using skip, flip, multiply. So I skip the first term 2. I don't do anything with it. I flip the second term. Mathematically speaking, this is actually what we call multiplying by the reciprocal, and the reciprocal means that the numerator 1 now becomes the denominator, and the denominator of our original fraction now becomes the numerator, the top number. So we flip it, okay, and then we are going to multiply straight across. Again, 2, if you think of it as a fraction, is the same as 2 over 1. Remember, all fractions are division problems, so 2 divided by 1 equals 2. I'm not changing anything about the value of this number, and I multiply top times top, bottom times bottom. 2 times 4 gives me 8, and 1 times 1 is 1, and 8 divided by 1 equals 8. And we see here that we have the same answer, right? We have 8 slices total, and when I do skip, flip, multiply, I have 8 for my final answer. Okay, example number 2. Let's go ahead and look at 2 thirds divided by 1/6. So we skip the first term, 2 thirds. We're going to flip our second term, 1/6, into 6 over 1. And then we're going to multiply. Remember, we do top times top, bottom times bottom. And we get 2 times 6 gives us 12, and 3 times 1 gives us 3. Remember, all fractions are division problems. 12 divided by 3 equals 4. So our answer is 4. Again, keep, flip, multiply is the same, or skip, flip, multiply is the same as keep, change, flip. Okay, it's just another trick that people use to help memorize what to do. So you keep the first term. If we're using those verbs, you change the division sign to multiplication, and then you flip the second term to 6 over 1. So the change is representing the change in the operation. And you, again, multiply top times top, bottom times bottom. All right, Let's look at some real world problems or some word problems to help us see what this looks like in application. So let's look at the cookie dough dilemma. If Sarah has 3/4 a cup of cookie dough left and each cookie requires 1/8 of a cup, how many cookies does she make? Okay, so as we're reading through word problems, we always want to start with what we know and make sense of that. So we know that she has 3/4 of a cup of cookie dough. That's the total amount that she has. And then she's going to divide that up into an eighth to make the cookies. So her whole amount is 3/4, and we want to know how many pieces of an eighth. If my cookie dough requires an eighth of what she has left of the dough, how many cookies can she make? So we are going to be doing 3/4 divided by 1/8. Now, if you want to do skip, flip, multiply, we're going to skip the first term and just rewrite it, flip the second term, and then multiply. Same thing if you change this to division to multiplication, and then flip, and you're going to multiply top times top, bottom times bottom. So 3 times 8 gives you 24, over 4 times 1 is 4, and then we would simplify that fraction. Remember, think of all fractions are division problems. 24/4 is the same as 24 divided by 4, which equals 6. So 24/4 equals 6. So my answer is she could make 6 cookies. All right, let's look at this problem with our manipulatives. So remember, Sarah has 3/4, so this represents 3/4 out of the whole amount. Okay, 3/4 of a cup of cookie dough left. So there's her cookie dough right here. And then we want to know if each cookie, so again, the way I get an eighth is this is my whole amount. Okay, each blue rectangle is representing an eighth, right? Because there's 8 in that whole red square. Okay, so I just need one of these. Each cookie, okay, requires this much dough, an eighth. And then here's the total amount of dough I have, 3/4. So I am going to see how many cookies I can make. 1, 2, 3, 4, 5, put the pen down, 6. So with the 3/4, I can make 6. With the 3/4 of cookie dough that's left, I can make 6 cookies total. Today you learned 2 different ways to divide fractions. First, we looked at using a fraction model, having a visual representation, and just drawing. Remember, when we're dividing fractions, we're thinking how many pieces of this fraction fit into this amount, which is also a fraction. So how many pieces fit into this amount? And when we draw it out, it helps us to visualize and make sense of what's happening when we divide a fraction by a fraction. We also looked at skip, flip, multiply. Skip, flip, multiply is how it works, and drawing a model is why it works. Why can we skip and flip and multiply? It's because we're doing repeated addition. In each of those sections, we're counting how many pieces fit into that amount, and that's why skip, flip, multiply works. Math is all about believing in yourself. It starts with a simple thought: I can do math. From there, it's about connecting new ideas to what you already know, making sense of not just how, but the why, and applying it to real life. Along the way, mistakes are going to happen, but they're not setbacks, they're just stepping stones. Every problem has a solution if you're willing to put in the work and not give up. Build the mindset of a problem solver, because in math and in life, working smarter, not harder, starts with believing you can. Only a genius can solve, can you? What fraction of the rectangle is shaded red? All 3 angles in the top right corner are congruent. Leave your answer in the comments below. And don't forget to like, share, and subscribe.